Okay, in D03 we learned all about friction and friction acting in one dimension. Okay, so we're only going to be talking about friction acting in one dimension, and typically that's going to be in the horizontal direction because we're going to be either dragging or pushing something along a surface. So it talks about the coefficient of friction. Coefficient of friction is found by taking the force of friction divided by the normal force, and then we have our Newton's second law. Acceleration is equal to force divided by mass, or if we rearrange that, force is equal to mass times acceleration. Okay, so from that we can get what we need by taking a look at the net forces, or the net force that's being applied to an object, gravitational force, the normal force, force of friction, and the applied force. So take a look at number one. Number one, we have a 15 kilogram block is pulled by a horizontal force of 30 newtons along a rough horizontal surface at a constant velocity. That's going to be important. Okay, so we have a 15 kilogram block, constant velocity, 30 newtons for the force that's being applied. Okay, what is the coefficient of kinetic friction? So we're looking for the coefficient of kinetic friction. Okay, so we're looking for our mu sub k. Okay, so the coefficient of kinetic friction is found by taking the frictional force and dividing by the normal force. Okay, so we're going to need force of friction and we're going to need the normal force in order to do this. So the easiest one to find first is going to be the normal force. Okay, so remember that the normal force acts perpendicular to the object. So we're going to go ahead and draw our free body diagram. We have a 15 kilogram block here, so 15 kilograms. Sorry that that's a little off center. So 15 kilograms. We have the normal force acting up. We have the force of gravity acting down. We know that those two have to be equal and opposite because it says that it's being dragged horizontally. Okay, so we don't have to worry about, we know that those two are equal to each other, equal and opposite. So our horizontal force being pulled is 30 newtons, so our force applied is 30.0 newtons. Okay, and then at some point we're going to need to find the force of friction in order to determine the rest of this. Okay, so let's start with the normal force. Okay, so the normal force is going to be the opposite of the force of gravity. Okay, so the formula for the normal force is negative mass times gravitational acceleration. Okay, so if we plug those in, we have negative 15 kilograms times negative, go ahead and put parentheses around this, negative 15 kilograms times negative 9.8 meters per second squared, okay, which gives us a normal force, excuse me, a normal force of 147 newtons. Okay, so we're going to tuck that away for later because we're going to need that in order to solve. Okay. The next thing we need to do is find the force of friction. Well, in order to find the force of friction, we first have to determine what the net force is on the object. So let's take a look at what that said there, that it's traveling at constant velocity. So the net force of an object is equal to its mass times its acceleration. Well, if it's traveling at a constant velocity, that means that acceleration is 0. Okay, it has no acceleration. It's traveling at a constant velocity. Acceleration is 0, which means that this whole thing goes to 0, which means that our net force is 0. Okay, and if net force is equal to the applied force plus the force of friction, that means that our force of friction has to be equal and opposite to the applied force. So our applied force was 30 newtons, so that means that our force of friction is the opposite of that, or negative 30 newtons, or 30 newtons to the left. So since our arrow is pointing to the left, we can just say that our force of friction is 30 newtons. Okay? And then the last thing that we need to do is plug these values that we've just found, 30 newtons in for the force of friction, and 147 newtons in for the normal force, and that will give us our coefficient of friction. Okay, so our coefficient of kinetic friction is equal to the force of friction, which is 30 newtons, 30.0 newtons, we'll need that for significant figures, divided by 147 newtons, our normal force. So I should go ahead and rewrite that. Let me do that really quick right here. This is going to be 30.0 newtons divided by 147 newtons gives me a coefficient of kinetic friction of, excuse me, pardon me, 0.2, oh, let's try that again, 0.204, okay? And coefficients, the coefficient of friction is a constant, so we don't have any units for that, so 0.204. All right, so for number 2 now, we have a 49 Newton block, okay? So what they gave us there is the force of gravity. So the force of gravity is equal to 49 newtons, okay? So is pulled by a horizontal force of 50 newtons, so our applied force is 50.0 newtons along a rough horizontal surface at a constant acceleration. So now we don't have constant velocity, we have constant acceleration. Our acceleration is equal to 6.0 meters per second squared. It says what is the coefficient of friction? So we need to find the coefficient of friction. We can only find the coefficient of kinetic friction because it is accelerating. Okay, so our coefficient of kinetic friction is going to be equal to, again, our force of friction divided by the normal force. It's being pulled horizontally, which means that the force of gravity must be equal and opposite to the normal force. So our normal force is going to also be 49 newtons, just in the up direction. So this force of gravity is actually negative 49 newtons because it's acting down. Okay, so what we need to do now is find the force of friction. In order to find the force of friction, we're going to first have to find the net force. Okay, and in order to find the net force, remember the net force is equal to mass times acceleration. Well, we know the acceleration. Acceleration is 6.0 meters per second squared. But what we don't know yet is we don't know the mass. Okay, so we need to find mass. Okay, so remember that the normal force, or the force of gravity, you can use either one. Okay, so the normal force is equal to negative mass times gravity. Okay, well, we know that the normal force is 49 newtons. We know that gravity is negative 9.8 meters per second squared. Okay, so we can solve for m by dividing both sides by negative 9.8 and then again dividing both sides by 1, or we can just go ahead and take care of those two negatives right now and just take 49 divided by 9.8. So 49 divided by 9.8 is going to give us 5.0 kilograms. Okay, so our mass is 5.0 kilograms. And now that we know the mass and the acceleration, remember the acceleration was 6.0 meters per second squared, so F net equals 5.0 kilograms times 6.0 meters per second squared, okay, which gives us a net force of 30 newtons. Okay, so our net force is 30 newtons, and now we can plug that into our net force being equal to our force of friction plus our applied force. Okay, so if our applied force is the 50.0 newtons, okay, and our net force was 30 newtons, that means that if we take the force of friction will be equal to the net force minus the applied force, okay, which would be negative 20 newtons. Okay, and since it's acting to the left, so we can say that the force of friction is negative 20 newtons, or the force of friction